Hello guys, I'm Merunas back again with this new tutorial for making your own ICO. Here you will learn how to create a crowd sale contract for selling your tokens. In the last video you saw how to create the token contract for basically creating tokens in Ethereum. But right now we are going to see how to create the ICO selling contract, which will allow you to distribute those tokens during an ICO during the limited time with a limited price. It's a bit complex. It's maybe the most complex contract that you will see, but it's great to know how to do it because you will find a lot of job opportunities regarding ICOs, so it's important to know this. Let's get started right away. So open your project just like before, go to your token folder, and as you can see I already have a crowd sale contract. Don't worry about that, just create a new crowd sale file, or you can call it ICO however you want. I will call it ICO this time. And the first thing that we're going to do is we're going to set up the version. Let me close the window. Okay, so we have the version. Now we need to import the token. Here's how we import it, because we will use that token later on. As you can see, we're using the import keyword instead of just copying the entire contract, because this contract is already big, so we don't really want to paste all this code in the same file. When we deploy this contract, we will combine all these files together and then paste them on Remix. But for now we are just going to keep it like this, just for making everything easier. Let's create the contract, the ICO contract. You don't have to use the is token because we already have the token available right here. When you import a contract, you have all the functions available everywhere, so you can just use that contract without having to inherit the functions. Contract ICO. Now let's define some basic functions that I'm just taking a look at the contract that I made before. Let's define some basic functions that we are going to use. First, the fallback function, which is public and payable. This is the fallback function. It doesn't have any name. This is the function that gets executed when you send Ether to this contract without calling any function. When you just use a send function directly without any function, this function gets called. And the payable only means that you can send value, you can send Ether along with the transaction. So it's important because we will use this function for purchasing tokens. It's also good to write comments to explain what is going on. This is the function. Like, I always start with to purchase tokens with the fallback function. Now I usually like to create a new function similar to this one called buy tokens, which is public and payable. All that you are seeing is just a way of doing this. There, you can do your own ICO token, you can create the function that you want. It's all up to you, but I'm showing you how I do it and how most of the people do it. It's basically the best way to do it. When you create an ICO contract, you usually want to start from scratch, because there are different variations, different contracts like this, like the token contract where you can import things. But the ICO is it's a different contract where you have to define your own things. It's not something that you can take and just use it, which you can, but it's always better to create your own version of the ICO, because you will have specific requirements that will be different for every situation. Now, to buy tokens directly. What else do we need? Let me take a look. These are the main functions. basically the ICO contract is for buying tokens. That's the whole purpose of the contract. Now let's define some variables that we would like to have, like start time, public start time. This is when the ICO will start. Public end time. What else? The rate. The rate is how many tokens you get for 1 Ether. In this case, I'm going to set up 5,000 tokens for 1 Ether. 5,000 to the power of 3, because remember that we have 3 decimals. So that will be 1 Ether equals 5,000 tokens. Remember that we have 3 decimals in the token contract, so you always have to add 3 zeros at the end, because we're always dealing with the smallest unit. So this will be like this, but because it's a bit confusing, it's better to just use E3, which is the same thing. What else? We need a counter function. You can create whatever variables you want, but I usually like to have this tokens sold variable. This will take care of calculating how many tokens have already been sold. People will be able to see how many tokens are being sold, which is very important. Max tokens sold. This is how many tokens you want to sell on the ICO, because you can sell a portion of all the tokens that you have in your contract. Let's say that you want to sell 20% of your tokens. You can sell only 20 million or 1 million, but in this case we will sell all of the tokens in the ICO, which is 6. This is 100 million, but we want to use the 3 decimals, so it will be this 100 million with 3 decimals from the token contract. Remember that. Tokens max. Now we need the token. This thing is just the address of the token that we're going to use, because when we create the ICO we have to set up the token that we're going to use, because this is how it works. You first deploy the token contract, then you deploy the ICO contract, and you take that token address and you use it in your ICO contract, because you want to use that specific address. So that's it. Now I have a notepad with some information, like create the crowd-sale contract with the main functions. These are the steps that you need to follow. Update the token contract for being able to distribute the tokens, or just use the tokens of the owner. This is, you will see later on how we distribute those tokens. Then update the token contract for blocking the transaction except the owner and crowd-sale. It is very important to not allow people to make transactions until the end of the ICO, because people will get the tokens when they send Ether. They will get, like, I send 1 Ether to the contract, to the ICO contract, and I get 5,000 tokens. He gets that immediately. So it's very important to not allow people to use those tokens for selling them in whatever exchange they want. It is not good because people will be able to sell those tokens before the ICO ends, which is very important to not allow. And here are some calculations. We will say later how we'll use that. So we need the constructor, which is a public. We also need an owner function. In this case, I want to have an owner. You can leave it without an owner. It's all possible. The owner is just the address of the person that deployed the contract. So the owner will be message sender. We also need to specify the token address that we're going to use for this ICO contract. So token is equal to this token address. It's also important that this token address is not empty. So we make sure that the token address is not address 0. Address 0 just means an empty address. Okay, we have all of that. Now let's create some modifiers, because we want to create these modifiers that only owner for specific functions require. Is equal owner And this, yeah, I forgot about one thing. It's also important to send the ether raised to the owner address. That's why we have this owner address, because we want to send that ether that gets raised to that owner address. It's very important. Now the modifier, this is a custom modifier that I want to create during ICO only. This requires that the time is less than the end time. This modifier blocks the function. If you're trying to execute a function before the ICO or after the ICO, you won't be able to execute it. This allows people to only allow the functions to execute the functions during the ICO. That's the purpose of this function. Start. And this, we will use this modifier here because we want to allow token purchases only during the ICO. To only allow token purchases during the ICO. To only allow the owner to execute the contract, the function. Now the start time and the end time will be Unix timestamps because Solidity deals with that way of the time. So to get the start time, we go to a page called this Unix timestamp. You see unixtimestamp.com. There we will set up the time that we want to start the ICO. Here we just enter a date like this one, like July 1st, and then we convert that to the timestamp, which is this number. Then we go back to our contract and we set up the address like this. This means that the ICO will start on July 1st. I mean June 1st. And I like to copy all this for making sure that people understand this is the exact time when this is starting. You know, this is the conversion. The end time, let's say that I want to end the ICO on 2019 on January 1st. So let's copy all this and paste it here. Also, let's copy this equivalent for clarity. Okay, now we have the owner, start time, rate. Let's create a function to change the rate, because the rate is how many tokens you're getting for change rate, how many tokens you are getting for your ether. So you may want to change that rate after deploying the contract, because things happen and you may want to change the rate after the contract is deployed. So only owner. Let's make this external, which is all executable by external people. To change the rate after deploying the contract. Let's take the rate here. Require that rate is bigger than 0, and require that now it is important to only allow to change the rate before the ICO. Now is less than start time. This, we are checking that we are executing this function only before the ICO. Now the rate will be this new rate. That's it. We are just updating the rate. The owner will be able to update the rate if he wants to. This is just for helping people because when you deploy the contract you may want to make changes, and it's important to be able to do these things, because once deployed the contract won't be able to be modified. Okay, we have all this. Now let's create this basically here we are just executing the buy tokens function, and here's where all the magic happens. We need to do several things here. First, we want to calculate how many tokens. Let me check that this is recording. Okay, it's working. Calculate how many tokens we are purchasing, because when you send Ether you want to know how many tokens you're getting. 2, we want to make sure that the tokens are not exceeding the limit. And finally, distribute those tokens. And I want to tell you that we will have to modify the token contract, because when you create an ICO you have to make changes to the token contract to be able to send those tokens. It's important to be able to send those tokens. There are different ways to send the tokens for the different users, but we will modify the token contract for being able to do so, and then send the Ether raised to the owner. Now we want to make sure, let me check, we want to make sure that when we are executing this we are not exceeding the limit of tokens. So check that the limit of tokens has not been exceeded yet. What I mean by that is, let's just check that the tokens sold are less than the max amount of tokens sold, because if we already sold 100 million and the maximum is 100 million, we don't want to keep selling those tokens, we want to return this function. Now, how many tokens we are purchasing, how we calculate that? How many tokens we are buying? Let's create a variable called tokens to buy, which how many tokens, let's say I sent 1 Ether, how much do I get? 5,000 tokens, right? So I make here a simple calculation. Basically for 1 Ether we get 5,000 tokens. So for X Ether, how many tokens do we get? So to get the tokens I just multiply these two, you can see X Ether multiplied by 5,000 tokens divided by 1 Ether. This way the Ether and the Ether gets cancelled and we just get the tokens. These are some simple mathematical calculations. So that's how we get the number of tokens depending on the amount of Ether that you send. So if you send 0.5 Ether, let's say you send, let's make the calculation. If you send 0.5 Ether here, I send 0.5 Ether, then I multiply that by 5,000 tokens and divide that by 1. I basically get 2,500 tokens. Of course 0.5 Ether, it's actually 0 until you get to 18 decimals. That's why we are dividing by 1, because 1 is not really 1, it's 1 with 18 zeros, because Ethereum has 18 decimals, you know. This is not really, this is, you know, all of this, and this is all of this, because Ethereum has 18 decimals and we are dealing always with the smallest unit. So that's how we get the number of tokens depending on the amount of Ether that you sent. So here's, let's paste that. This is the rate. As you can see, this is the rate that we set before, the rate multiplied by the amount of Ether that he sent, which is message value, divided by 1 Ether. You can just say 1 Ether. because in Solidity you have this, you can convert the number to an ether, which is 1 with 18 zeros. That's how we are calculating that. That's the tokens to buy. Now make sure that those tokens are not exceeding the limit. Now if we are exceeding the limit, what happens if, let's say that we already sold 98 million tokens. We already sold all of these. This is really the tokens sold variable. Now, and I am buying right now. I'm purchasing 103. I'm buying like 10 million tokens during this transaction. So that will be tokens sold plus tokens to buy, which will be 108 million tokens. There's a problem here, as you can see. The problem is that we are trying to buy more tokens than they are available. We're exceeding the limit of 100 million tokens. We only want to sell 100 million. So how we deal with this? There are two different options. You can, when a user tries to buy more tokens that are available, you can just reject the transaction and force him to send the exact amount for getting exactly 100 million tokens. Or you can take those 108 million, return 8 million to the user, returning the ether, and just buying 2 million. You know what I mean? He buys 2 million. And the other 8 million, which is 100 minus 108, gets returned to the user. He receives the corresponding amount of ether back. So now let's forget about this and let's calculate that. So sum, let's make this sum of tokens to buy. It's important to be clear with your variables. The length of the name of the variables, it doesn't matter. You want to be as precise as possible. Write long variables, descriptive variables. It really helps to understand the code and to really make a clean code. Sum of the tokens to buy. So this is tokens sold plus tokens to buy. Now what we are going to do with that is, if we are exceeding the limit, how do we know if we are exceeding the limit? If the sum is bigger than the max of tokens sold. It's a bit complex, so if you don't understand something, make sure to go back to the video and repeat what I just said and make your calculations yourself, because once you do this you will understand what is going on. But you have to do is to be able to really know how this is done, because in a real ICO you want to allow people to buy as much tokens as possible and to get exactly to the limit. So here's the thing, if we are exceeding the tokens to buy, let me check my contract. Okay, first we have to calculate how many tokens are exceeding the limit. This is the exceeding tokens, which is the sum, which is, in this case, think of this as 108 million. This is the sum minus the maximum, which is 100 million, max of tokens sold. In this case the exceeding tokens will be 8 million. This is just an example. Now what we're going to do with that is we're going to take those exceeding tokens, 80 million tokens, we are going to convert those tokens to ether back and return that ether to the user, because the user didn't really buy the tokens yet. he just sent Ether and he wants to get the token. So we are going to convert those tokens. I'm adding a lot of comments so you understand what is going on. Convert the exceeding tokens. It's good to, if you follow the tutorial, if you copy the same code as I write it, because you will really practice this and you will understand what is going on. Because if you watch the video without even practicing, you will forget all of this and you will be confused, because there's a lot of different concepts that you have to apply. So pause the video, write the code, and try it yourself. Convert the exceeding tokens to Ether and send them back to the buyer. So how would we convert the tokens to Ether? We can create a new variable called exceeding Ether, which will be, how do we convert 8 million tokens to Ether? So let's go back to our calculations. Remember this. So if we want to get the number of tokens, we want to get the number of Ether here. So how many Ether? In this case, we have 8 million tokens. We are going to multiply this. If we have Ether and we want to get the Ether, depending on the amount of tokens, we just take the Ether, multiply this 2 and divide by this 1. So X Ether will be 1 Ether multiplied by X tokens. In this case, it's 8 million tokens, divided by the rate, which is this one, the rate of tokens. That's how you calculate. Let me show you. So exceeding Ether, let's copy this directly. It's good to copy the code and to make sure you're not making mistakes. So 1 Ether multiplied 1 Ether, you have to write this like this because it's a special variable in Solidity. 8 million tokens is just the exceeding tokens, if you remember, divided by the rate. This is the rate of tokens. Now what we're going to do with that, we already have the tokens to Ether and we have to send them back to the buyer. We do that with MC sender. This is the address of the sender. We're going to transfer that exceeding Ether. We are using the transfer function from Solidity, which sends Ether to that user. We're doing that. Now it's important to create a variable to calculate exactly how many tokens we are buying. Tokens to buy, tokens purchased. This is how many tokens we are actually buying. So tokens purchased in this case will be the, if you go back to here, tokens sold in this case will be 98 million. This is just an example. Plus tokens to buy, if we want to buy 5 million, we get a total of 103 million. We just return the exceeding Ether, as you can see. So we have to buy only, we take this sum, so it will be, we want to calculate how many tokens there are from 98 million to the maximum, which is 100 million. We want to know how many tokens we are really buying, because we have returned 3 million to the user back, because it is exceeding the limit. So this is basically, we take the max tokens sold minus the tokens sold. That's the tokens that we're buying, which is 2 million in this case. I don't know if you're seeing it. To max tokens sold, if this is 100 million tokens minus tokens sold, which is 90 million in this case. It can be 92, 90, 80, doesn't matter. Tokens purchase are those. There are different ways to do this. In my other contract I did the following, because I created the contract before this tutorial to understand how to do it. What I did before is tokens to buy minus exceeding tokens. As you can see, in this case we want to buy 5 million. Let's say that we want to buy 5 million. If we take the exceeding tokens, which is 3 million, we get 2 million, which is exactly the same thing that happens here. So there are different ways to do the same thing, so try to find your own solutions. In this case I'll go with this one, which is the tokens that we are just buying 2 million tokens. Basically this is all it means. Now we need to, what if we, every time you make an if, you have to make sure that there is an else in case we are not going through that if. So what happens if we're not exceeding the limit? This is only if we are exceeding the limit of most tokens in this purchase. If we're not exceeding the limit, basically take the tokens purchase and make them tokens to buy. Basically we're talking tokens to buy and we're buying all of them. Now how we distribute those tokens? Here's a problem here. First we have to update the tokens sold variable by adding tokens purchase, and we need to send them. How do we send the tokens? This is a really important issue, because you can't really send the tokens like that, because if you remember, in the token contract the owner is getting all of the tokens here. The owner is getting all of the tokens. So we need some way to take the owner balance and send it to this user. How do we do that? Well, there are different ways of doing this. We can transfer those tokens to the ICO contract, but what I like to do is I go to the token contract and I create a new function called distribute ICO tokens only crowd sale only ICO. This function sends Ether from the owner's balance to the purchaser. Here's the address of the purchaser or of the buyer and the amount tokens to buy. Yeah, basically this function allows us to send the tokens from my own balance, the owner balance, to the user that is buying those tokens, because you have 100 tokens in your balance, but the ICO contract cannot access those tokens. You cannot execute a transfer function. You have to use a custom function like this one to send the amount to the user. Let me add a comment here to set up the balance of the owner to the total supply. So we are going to do, as you can see, I created a modifier called only ICO. Let's make this external, by the way, or not. Let's make this public because it may cause some problems. So let's create a modifier called only ICO. Only allows the execution of the function by the ICO address. We also need an address. let's call this ICO. Basically we're taking the ICO require message sender is the ICO. This means that we only want this function to be executed by the ICO contract. If you remember, each contract has its own address, so it's like a new person. Now we need a way to set up ICO address. This is the ICO. It will be public only owner, because we only want the owner to be able to do this. So let's create an owner address. This function it is just to set up the ICO address for being able to distribute the tokens. Yeah, because we are doing all this in the token contract, because the token contract has access to the balance of each user. What I'm basically doing is I'm adding, you see this is a mathematical. Okay, so the thing is, we have this balances function, which is over here. We have this balances variable, which we can update with whatever value we want. We can take the balance of any user and we can update it from this contract, because here's in this contract we have all the balances. We have access to all the all the tokens from each user. So we set up the address. Let's go back to this. Let's set up the ICO address required. It's always good to check that the address is not empty. It's not address 0. And then ICO is this one. I also need to create an owner. Let's create an owner. The owner will be constructor owner is message sender. Balances of the owner is all the total supply. Let's create a modifier called only owner. Require. You are already familiar with the only owner modifier, I believe. So the only owner to only allow the execution of the function by the owner. So we have this only owner. We are doing this for only setting up the address of the ICO and for being able to distribute those tokens. So we're setting up the address of the ICO. Then, if you remember, we have all the balance, all the total supply is in this address. The owner has all the tokens. Remember that. So what we're going to do in this distribute ICO tokens, we're going to take the balances of the owner and we're going to balances owner. We're going to use the sub function, which is just subtracting. The sub function, it's like making a subtraction but with safe math. This is to avoid overflows. You see, it's just subtracting two numbers, but in a safe way to avoid underflows and overflows. You may be familiar with that. So we are subtracting the tokens to buy. We're taking the balance of the owner, which has 100 million tokens. We're reducing that balance, and we are going to take the balances of the sender, of the buyer, and we're going to increase the buyer balance by sum or add the tokens to buy. Basically, we're moving the tokens from my balance, from the owner balance, to the user that wants to buy those tokens. We are using safe math again with the add function. You see, we're taking the balance of the buyer and we are increasing that balance by the tokens to buy. Now we let's make some checks to make sure that the buyer is not empty. It's not an empty address, and to make sure that the tokens to buy are bigger than 0. So you have to buy more than 0. Well, I will remove this because maybe you want to buy but you're getting 0 for some reason. So let's skip that. Simple. Now, what else? We're just updating the balances. Let me check this contract to make sure I'm not missing anything. You can see this ICO contract, it's quite big. It has different things, it has more things. This is what I'm showing you here is the basic ICO contract. You have different variations where you can change the price dynamically, the rate, and different things. But that's more complex. We don't have to worry about that right now. We're increasing the total supply. You can do that whenever you want, and require that the tokens raise. Well, don't worry about that. So basically, we are distributing the ICO tokens. This function is working. Okay. So we are going to our ICO contract, and to distribute the tokens, we go to the token. If you remember, we have this token set up already here. Wait, the token must be like this token. We are just instantiating the token address. We're taking the token address and we are converting that token address to the contract for being able to use the function. You can see we have the token here. We are just taking the address and we are converting that address to a contract for being able to use the functions. So we go to the token, which is a contract, the token, and we can execute the distribute ICO tokens. Distribute ICO tokens. Now, what we want to do is we want to take the buyer. The buyer will be the message sender, and how many tokens he will buy. In this case, it's tokens purchased. Now we take the ether raised and we send that ether transfer message value. Well, here's a problem because the value is not message value is the initial amount that the user is sending to the contract, but because in this situation we are returning some ether to the user because it is exceeding the limit, so we have to send not the message value but the remaining amount, because the exceeding tokens in this situation is reducing the amount that the user sent. So if I sent 1 ether and I'm exceeding 0.5 ether, the remaining amount will be 0.5 ether, so I will buy only 0.5 ethers. I will only buy 0.5 ether worth of tokens. The remaining 0.5 will be returning to me because I'm exceeding the limit of tokens to purchase. So if I want to buy 110 million, I'm exceeding 10 million, and in those 10 million maybe 2 ether, so I get those 2 ether back, and the other amount, which may be 5 ether, gets sent to the owner. So let's create a function, a variable called amount ether raised. Let's also create a variable here called ether raised. Ether raised, yeah. Let's change this to ether raised with this underscore, and the ether raised will be the message value. Now we're going to take that ether raised, and as you can see, we're transferring the exceeding ether. So what we're going to do is ether raised is equal ether raised, or ether raised minus exceeding ether. We're basically taking how many ether you sent and we are reducing that exceeding Ether because we sent those Ether back. And we are going to take that Ether raised and we're going to transfer that amount to the owner. We are also updating the function, the variable, I mean, Ether raised plus equal Ether raised. We're increasing the amount of Ether that we already raised just to have some kind of logging of understanding what is going on. As you can see, the buy function is quite big. It's the main function. It's complicated, but it's important to make sure that we're covering all the different situations. Now basically this contract should be working right now. We have all the functions, we can purchase tokens, we can update the rate, and we are ready to use it. Of course we will have to deploy a new version of the token. Now here's what we're going to do. We're going to first deploy. First I want to tell you about the importance of auditing this contract, because this contract is, you will have to write tests for making sure all the functions are working, maybe 10-20 tests, doesn't really matter, and you will have to get somebody to audit this contract because the ICO contracts are dealing with a lot of money. Sometimes they are dealing with millions of dollars, so it's really important to make sure there are no problems, especially in this buy function, because as you can see we're increasing the amount of Ether, we're reducing the amount, which is very dangerous. You may make some mistake and people will lose money if you make some mistake, and Ether will be lost. There may be vulnerabilities. It's important to really get somebody external, not you, because you develop the contract, somebody external to audit the contract. It's really important to audit the ICO and the token contract to make sure there are no problems, because those contracts will be there for a long time and they will deal with a lot of money. So get someone external. If you have written the contract, the ICO contract, get someone external and audit that contract. You may, as an Ethereum developer, you will get a lot of auditing jobs for auditing ICOs, because people understand the situation. They know that we're dealing with a potentially dangerous contract, and you will get job offers where people show you this type of contract, this type of ICO contract, and they want you to audit the functions to make sure everything is working properly. This is just the beginning. As you can see, this is a very complex contract, but this is advanced for people that already know how to create contracts, how to deploy them, how to create decentralized applications. As you can see, this is all increasing in complexity, but the thing is that this added complexity increases your payment. It makes you more available, more of a more capable of getting more complex jobs. If you think about it, this is not that complex. If you have to break down everything like I did in steps. It's very important to create these steps. Calculate how many, make sure I know the steps because I already made several ICO contracts, and that's it. When you are creating the ICO contract, it's very important that you get the specification right, because some people want a minimum amount of tokens to purchase, a maximum amount of tokens to limit, because there has been situations where people buy all the tokens of the ICO and a few people, like 2 or 3, get all the tokens when there are maybe 1,000 potential buyers interested in getting in the ICO. So it's important to limit. It depends on what you want to do in the ICO. It's when you're dealing with a client, get the specification right, ask them questions, write them with the exact thing that you want to create, and make sure that I understand the situation, that there are different possibilities. This could happen, this could be a problem. So okay, let's forget about that and let's deploy these contracts. So first, when you're deploying the ICO, you first have to deploy the updated token contract with the new functions, the new ICO functions. Then you have to deploy the ICO contract with that token address in the constructor, because we have a constructor where we set up the address of the token in the ICO contract. Then you have to execute the set up ICO address function from the token contract. You have to go to your token contract and execute that function with the ICO address. This is important for being able to distribute the tokens, because as you can see, we are making sure that only the ICO is able to distribute the tokens. The only reason we are setting up the ICO address is to only allow this function to be executed by the ICO. We only want the ICO to be able to distribute the tokens. We don't want any other user to be executing this function. It's important to limit who is able to do what and to make sure they are capable of doing that. Execute the setup ICO address from the token with the ICO address. Then you can update the rate of the ICO before starting. But before all of that, make sure the start time and end time of the ICO are correct, because you won't be able to update them unless you create a function to update the end time or the start time. So it's make sure the times are correct. Also make sure the rate is correct and the max tokens sold is correct, because you may want to sell only half of your tokens, you may want to sell only 50 million. It depends on your preference. Okay, these steps are really important. When you create your ICO, after finishing the contract, write the steps like I just did and save them somewhere, because you will have to deploy the contract maybe several times because you make changes to the contract. And it's important that you know that you have to set up the addresses and update the information. So that's that. Let's deploy this ICO contract. So copy the token. As you can see, first we make sure that the things are correct. They are correct. Now first let's deploy the new token. So go back to Remix, remove that, paste that ICO. Okay, first there's a problem here. Balances. Let's update that balances buyer. Okay, let's deploy this. First we have to connect to MetaMask. In this case, I'm going to deploy to Rockstone. You can deploy to wherever you want. If you are running a real ICO, you will have to deploy to the main network, because that's where the real money is. Okay, let me run this thing. As you can see, we are running the Rockstone thing, and let's deploy the token. Let's increase this gas price to speed up the transaction and submit that. If you increase the gas price, the transaction will be processed earlier by the miners. Let's wait for this to process. And let's create this token address. I usually use the notepad for writing this kind of information, because it's important to have everything somewhere safe in an organized file like this. Crowd sell address. As you can see, we have the address here. Copy that address of the token and paste it here. Now if you take a look at the steps, deploy the updated token contract, deploy the ICO contract with the token address. Now, because if we are importing the token, we are just going to copy all of this, because we have the token already there, and we are going to paste it below the token. So let's paste that. There's a problem here. Uint tokens sold. Line 219 token consult, update your own files. Okay, we have the contract ICO, which is below the token contract. That is important. Let's deploy the ICO. Copy your token address. Deploy the ICO contract with that token address in the constructor. Copy that address and paste it here. Paste that address here and deploy it. As you can see, there are no errors, there are no warnings. That's because we made a good contract. However, before deploying, you have to write tests to make sure that this function, the buy tokens function, is working, that you are distributing the tokens, that the limits, that the contract is stopping when the time is ended, when you raise all the amount of tokens. All those things are important. Let's wait for this to process. We are deploying the ICO. Then we will execute the setup ICO address from the token contract. Let's wait for this. Okay, we have the ICO there. Let's copy that address. Let's paste the carousel address here. And then we are going to go to the token contract, which is this one, and we are going to execute the setup ICO address with the new address. Make sure they are the same. Okay, setup. Let's increase this and submit. We can go back here and see. After that, you can update the rate of the ICO. That's it. We can try to buy tokens. The problem is that the ICO is not started, so we have to wait until we get to this date. Then we can go back to this address. Now, how you buy tokens? You take the ICO address, which is this one. You go to MetaMask and you click the send button. We are sending directly to this address. You can send 1 Ether. If you send 1 Ether, if you remember, we will get 5,000 tokens. You send 1 Ether to this ICO address and you get, the problem is we are getting an error because the ICO has not started yet. As you can see, the start time, we are not yet in the start time. So once you get to this date, you will be able to do this, to go and send. This is how you buy tokens. Wait, you execute the send function from MetaMask or any other. You can use my Ether wallet. So from my Ether wallet, if I go here, okay, send tokens. Can I use MetaMask? Yes. Basically, you connect to your account. Let me use the Robston. Okay, I'm connected to Robston. So what I do is the same thing. I paste this address and I send 1 Ether because I want to send 1 Ether. And it's important to increase this to maybe 300,000 because when you're sending Ether this way, you're executing this function, the buy tokens function, and this function, as you can see, it's quite big, so they will need more than 2,000, maybe 300,000 gas. The gas depends on the size of the function, so set up like something like 300,000 and the remaining gas will be returned to you. So if you end up using only 100,000 gas, you will get back 200,000. Then you click on generate transaction, send transaction, and you send the transaction. Now you confirm the transaction. As you can see, we're not getting any error, but this transaction will fail. I'm telling you right now, this transaction will fail. If we are in the ICO time, if the ICO has already started, this transaction will process properly, will execute, and you will get your tokens. After the transaction has been mined, you will get your tokens, and you will be able to go to your token address. You can go to your token address, go to Etherscan. You basically go to the token address here, I mean, you can go to token, and you will see that there is one address, the total supply, and all of this. Okay, you can see here that we need a total supply function. We need a total supply function. That's why we were doing that. So remember that. If you, in the past video, I deleted that function because I didn't really want to use that, but it's important to have it. So just change your contract and so on. You can see it is failing because we are not in the ICO time. But if you are in the ICO time, this will go through. You will get your tokens and so on. You can see the gas used. So that's it. You now know how to deploy a contract. You now know how to create an ICO contract. You now know how to update your token contract for using that ICO and distributing the tokens. You now know how to deploy the ICO contract and how to create all of this complex situation, and how to buy those tokens with my Ether wallet and MetaMask. You just send Ether directly to that address and you get the tokens back. I mean, the tokens are set up to your address, so you don't really have to do anything. You get the tokens after the contract executes. So hope you learned something useful. Hope you now know how to create ICOs and practice this. What you just learned, go ahead and practice yourself. Make your own ICO. Try different things like setting up dynamic rates. Things like there are dynamic rates where you can set rates like, I want to half of my tokens, I want them to be for $1 each, and the other half for $5 each. You can do all those calculations. It's up to you. Just practice this, try to make different things. I made them on my own, so this is how I do it. As you can see, the contract is quite big. There's 300 lines. When it comes to Solidity, 300 lines, it's a lot, because we are using a very specific code which is limited by the blockchain, which has to be secure. So this is all that there is to it. And you now have a very powerful tool. You now are able to create ICOs. You can go ahead and create your ICO, deploy it. You can go to clients and get ICO jobs, which are probably the best jobs out there, and work on that. So thank you for attention, and see you in the next video.